Alright, so today I'm going to discuss eusociality.
Alright, so eusociality is the highest level of social organization for animals. It involves a fertile queen which rules over a hive of infertile workers. Now, the workers use a division of labor to help support the queen and to raise the queen's offspring, which are their siblings. Now, some notable examples of eusocial creatures include ants, bees, wasps, termites, and this last one, which is my favorite, albeit fictional, the xenomorph, which is the entire reason I'm making a video about eusociality. Now, there is in fact a mammalian creature, which is also eusocial, the naked mole rat. So it isn't just insects and insect-like creatures that get all the fun with caste systems. Now, throughout this video, I'm going to focus on these top four for examples of eusociality, as they are the most common. However, before I get into that, I will point out that there are definite differences between each of these when it comes to the specifics of their eusocial structure. Now, I'm going to start with the life cycle, because it is fairly similar for the eusocial creatures. Now, most of them have holometabolism, also known as complete metamorphosis. Now, this starts with the queen, which births a larva. Now, the larva can either be fertilized or unfertilized. If it is fertilized, it is diploid. This means it has two genes, one from its mom, one from its dad. Or two sets of genes, I mean, not just two genes. If it is unfertilized, it is haploid, which means it has one set of genes from its mom. Now, this setup is known as haplodiploidy, because, you know, it's haploid right here, or it's diploid. Now, the diploid creatures are the females, while the haploid creatures are the males. Now, after the larva stage, the larva cocoons itself into the pupa stage. Well, it goes to the pupa stage, which is essentially a cocoon where it metamorphosizes into an adult. Now, I'd like to point out that complete metamorphosis is not unique to eusocial creatures, because you're probably noticing that this sounds similar to butterflies, which are in fact holometabolistic. Now, as I mentioned, after the pupa stage, it goes to an adult, which, if it's a female, means it becomes a worker. If it's a male, it becomes a drone. Now, the worker, as the name would imply, does most of the work around the hive, raises the young, gathers food, and helps maintain the hive. The drone, however, its sole goal is to mate with the queen. That's it. That's all it has to do. Now, in some cases, either due to genetics from its birth or due to a special diet fed to it as a larva, the larva may become a queen after the pupa stage. In other select cases, it is possible for a worker to metamorphosize into a queen. But either way, a queen develops, thus completing the life cycle. Now, this is not the case for termites, which are hemi-metabolistic. Or incomplete metamorphic. Now, hemi-metabolistic creatures do not have a pupa stage. Instead, the larva is essentially a mini form of the adult. Also, they don't have drones. They have kings. The difference being, a drone mates with the queen once and dies. The queen just stores all the genetic material. A king, however, mates with the queen for life. Still, all it does is mating. There is another caste, essentially, which is the soldier. Now, for most of the other three, the ants, wasps, and bees, workers essentially take on the role of a soldier. However, for termites, they have a specific genetic difference that will become the soldier. But there, that is the not at all confusing life cycle of eusocial creatures. Now, I'm going to take a bit closer look at the worker. Now, as I mentioned, the worker does the work, which can pretty much be boiled down to one of three tasks: raising the young, maintaining the hive, or gathering food. Now, typically, but not always, there are exceptions, the youngest of the workers raise the young. For example, the first 1 to 2 days of most bees involves them raising the young. Then they can typically move on to maintaining the hive, building it, repairing and expanding whatever they happen to be living in, being the beehive, anthill, or wasp's nests, or a termite mound. Then the oldest move on to foraging, which could be, gathering for food. It could also be, finding food or exploring, maybe looking for a new place to nest, or, for all except termites, being a soldier, which is really kind of a subclass of foraging. Now, the reason the oldest do this is because it is the most dangerous, because you're actively outside the hive. Think, you can squash an ant that's on a sidewalk, you can't really squash one that's in a hive. So, they have the oldest do it, which are most likely going to die of natural causes soon anyway, so not as big a deal if they, get picked off by a predator. Now, as I mentioned in the life cycle section, termites have the separate class of soldier. Now, a soldier is honestly kind of a generous term, because pretty much what they do is when there's a breach in the hive, these soldiers get together and pretty much just block the breach. They pretty much just create a wall, because most soldiers typically have abnormally large heads, so they pretty much just stick their heads where the breach is, or if it's too big, they get a bunch of other of the eusocial creatures or a bunch of other soldiers to stick their heads where the hole is and just create a wall so the intruders can't get through. Meanwhile, the workers repair the damage. Now, a lot of times, the workers repair the damage so that the soldiers are blocked out of the hive, so the soldiers essentially sacrifice themselves for the betterment of the hive. However, soldiers being kind of generous because they don't really go to war. They essentially just create walls, really. I'm also going to take a more in-depth look at the queen. Now, the primary purpose of the queen is to create more offspring, whether they be workers, drones, or in the case of termites, soldiers. And popular to misconception, the queen really doesn't run the hive. For the most part, workers, or drones or soldiers, are pretty much independent and run on their own. Queens are really just there to create more offspring. Now, there are a couple of different ways the queen can go about this. The first, and most common, and this happens for ants, wasps, and bees, is a drone comes along and mates with the queen once, and then it's dead. The queen then stores the genetic material from the drone, and so whenever it wants to create females, it accesses genetic material, and thus it has females. And remember, for the males, they're haploid, so the queen does not need the genetic material from the drone for them. It has everything it needs for them, because they're unfertilized. Now, if they happen to be termites, and you have a king, well, the king doesn't die after mating. The king mates with the queen for life. So, whenever the queen wants to make a batch of females, it simply mates with the king. Now, there are also a couple different ways that queens can develop. The first, and most common, and this happens for ants, wasps, and termites, is the queen is simply born royal. Due to genetics, the larva will just grow up to be a queen. Nothing will change about that, all genetics. Now, another way, and this is what happens for bees, is the larva is born normally, but it is fed royal jelly. Now, this is a special substance produced by the previous queen that has pheromones injected into it. Now, thus, whenever the queen dies, for example, the workers will feed a select larva the royal jelly, and that will cause it to become a queen. So that's another way a queen can develop. Now, I'd also like to point out that queens are not necessarily the only reproductive females. There are, in fact, some workers that are also reproductive. They're not queens, but they can reproduce. And this is the case for termites and for ants. For ants, they're called gamergates. And there are, in fact, some hives that have no queen, which are called gamergate colonies. There are also some hives that have multiple queens. So it's not necessarily true, I mean it often is, but it's not always true that there is in fact just one queen per hive. For termites, say the old queen dies, they can recruit a few of these special reproductive workers and have them fill the role of reproducing in place of the queen. The goal of every species is to pass along its genetic material. This is because genetic material that does not want to pass itself along doesn't pass itself along, and thus it dies out pretty quickly. As such, how could a eusocial system evolve? Wouldn't it make more sense for ants to raise their own offspring? I mean, that's what humans do. We don't raise our siblings. At least not in most cases. Well, to answer that, first I'm going to look at why humans have their own kids. Now, for a normal human, they have 2 sets of each of 23 chromosomes getting a full 46. This is known as being diploid. Now, to reproduce, they need to split that diploid set up and have 1 set of each of the 23 chromosomes. This then is known as haploid. Hopefully those 2 words sound familiar. Now, for reproduction, a haploid set of the 23 chromosomes from a female needs to join up with a similar set from the male. So they come together and they produce, bam, another set of 46 chromosomes. Now, you have 50% of your chromosomes are from your mom and 50% are from your dad. Now, let's say you have a sibling. Now, both you and your sibling have 50% of your chromosomes from your mom. So you have 50% and your sibling is 50%. This means that on average, you and your sibling will share 25% of your chromosomes from your mom. And the same situation works for the chromosomes shared from your father. Now, we can add these 2 up, and we figure out that on average, you share 50% of your chromosomes between 2 siblings. Now, in every situation, you always have 50% of your chromosomes in your offspring. So you have a kid, you have exactly 50% of your genes in that kid. Now, for siblings, this is on average. So yes, technically you could be more related to your sibling than you are to your own kids. However, it could also be that you are a lot less related to your sibling than to your own kids. As such, it's best to take the safe route and have kids to ensure that at least 50% of your genes are going to continue on. However, this is different for ants. Now, for an ant female, the ant queen, yes, the ant queen is diploid. And so it has to go through the same process that the human does and switch its genes to haploid. However, the ant male already is haploid. So it doesn't split its genes apart to be even more haploid. Instead, it takes its genes and transmits a full 100% of the genes to the offspring. So all of its genes get copied on. So when the ant queen and a drone, or king potentially, combine, they create a diploid. Now again, the ant siblings share 50% of their genes from their mom for each of them, which means that on average they share 25% of their genes with their mom and between each other. However, for the genes from their dad, they have the exact same copies of their genes from their dad. One worker has 100% of the genes from their dad. The other worker has, again, 100% of the genes from their dad, which means that the 50% of their genes from their dad are exactly the same. So if we add these up, we find that they have a relatedness of 0.75. They are 75% related between siblings. For offspring, however, their offspring would still be exactly 50% related to them. So they are better off raising their own siblings because more of their genetic material is going to be passed on. So that is thus why eusocial creatures have the hive structure with only really, usually at least, remember there are exceptions, one fertile queen, and they help raise their siblings. However, this assumes that there is only one male mating with the queen. This may not be the case. It could be that multiple drones mate the queen, so you could have different fathers, and thus the relatedness would be a lot less. However, also, because there isn't a whole lot of emigration or immigration but with a hive, it's most likely that the drones mating with the queen are the queen's brothers. So there's a lot of inbreeding that's probably going on, which means that the relatedness value is probably a lot higher. Which means that these two effects probably balance out, and if anything, they're probably even more related than 75%, thanks to inbreeding. Now, while there is still some debate as to whether or not these theories are fully accurate, these are the best, and they know that something is at least along these rails as to how the eusocial system could develop.
Now, I would like to point out that for everything I mentioned, there is probably at least one species that is an exception to it. So this is just the general case for eusocial creatures, and not a hard and fast rule that's true for all of them, but at least most of them. But nevertheless, I hope you enjoyed it, hope you learned something, and see ya.